Okay, Chapter 2 and Section 2.1, Basics of Functions and Their Graphs. So we'll start with some definitions here. A relation is a set of ordered pairs. So that's not scary. Set of ordered pairs. The domain of a relation is a set of all x coordinates. The range is the set of all y coordinates. So domain, set of all x coordinates, range, set of all y coordinates. So if we have the relation 4, 3, 5, 1, 6, negative 7, 7, 3, it is a relation with a domain of 4, 5, 6, 7, and a range of 1, 3, negative 7. Note the domain are just the numbers 4, 5, 6, 7, not the interval 4 to 7. The interval 4 to 7, and students forget about this, is all the numbers between 4 and 7. 4, 5.5, 5.3219, 6.1785. And so you couldn't say the interval 4 to 7, that the domain is just the four individual numbers of 4, 5, 6, and 7. Interval notation would be wrong because we only want the four numbers 4, 5, 6, and 7, not all numbers. Then our next thing, a function is a relation in which each x coordinate is paired with exactly one y coordinate. That each x is paired with exactly one y. So example 1, determine whether each relation is a function, y or y not, find the domain and range. So a function is a relation where each x is paired with one y. So when I look at this, 2 is paired with 4, and I don't see 2 paired again. 6 is paired with negative 2. I don't see it matched up again. Negative 12 is paired with 8, and 7 is paired with 8. So now these two guys are paired with the same number, but each x is paired with one y. And so another way to say this, a function is a relation in which each x is paired with exactly one y. Another way of saying this is, or there are no repeated x coordinates. That's another way of saying it and a little more illustrative. There are no repeated x coordinates. So when I look at this and I answer the question whether it's a function or not, the answer is yes. There are no repeated x coordinates. And then they ask me for the domain. And the domain are just going to be the numbers 2, 6, negative 12, and 7. My x coordinates. And my range is going to be 4, negative 2, and 8. Repeated y coordinates aren't a problem when we're talking about just functions. It's repeated x's. So same thing for the same question. Next one, we've got 3, 5, 8, 2, 4, 6, 3, 7. And the answer to whether it's a function or not is no. I've got a repeated x coordinate. But I can still talk about the domain and range. The domain is 3, 8, and 6. And the range is 5, 2, 4, and 7. But the big things on this first page is functions. 1x goes to 1y. 1x goes in, 1y comes out. Each x is paired to a single y. Domain, the set of your x coordinates. Range, the set of your y coordinates. Okay, moving on a little bit. While ordered pairs are a good way to understand the concept of function, the concept that functions match or pair each x with precisely one y value, the ordered pair format is not what's most commonly used to represent functions. Generally, function notation is used. More common is an expression like this: f of x equal 2x plus 4. That is read, f of x equals 2x plus 4. The f is the name of the function. Other common letters used are G and H. The x is the independent variable, and the 2x plus 4 is called the rule. One of the most important things we must be able to do with a function notation is be able to find functional values. So let's let f of x equal 1/3 x plus 6. Find and simplify each of the following. And so all this means, and I'm going to beat this to death, even on this easy one, I'm going to beat it to death. What this means is replace the x in f's rule of 1/3 x plus 6 with -3 and simplify. That notation, f of whatever, always means replace and simplify, always. So in this case, I've got 1/3 times -3 plus 6, which is -1 plus 6 for 5. Done deal. And then I just happen to graph this, and we'll be talking much more about graphing these things later, but there happens to be the graph. And what I want to note is if I go to 1, 2, 3, so there's -3, and I go see where that point is, I have the point -3, 5 on the graph. And that's one of the first relationships that we're going to start building between functions and graphs. That f of -3, 5, it's your x coordinate that goes in and y coordinates come out. So f of -3, 5 is the same as the point -3, 5. And we can see that on the graph. And that's all written down here. Observe the point -3, 5 is on the graph. Recall f of -3 equals 5. So we see the x coordinates or x values go into a function and y coordinates or y values come out. That means that domain values, x's, go into a function and range values, y values, come out of a function. Domain go in, x coordinates go in, y coordinates come out. Domain values go in, range values come out. We're going to keep working with this guy right here on to the next page. F of -2x, f of -2x. And it means the same thing. Now this has a tendency to bother students because it's not going to be a pretty nice, neat answer like -5, like 5 was, but it means the same thing. Replace the x in f's rule of 1/3 x plus 6 with 2x and simplify. So we're going to get 1/3 times -2x plus 6, and all we can say is that that's -2/3 x plus 6. And then you stop. That's the answer. For some reason, I have so many students that will now continue, and they will throw in an equal to 0 there, and then, well, I don't know why that just flashed off, but it did. But anyway, continue on. So many students, I'll have so many students that don't want that to be the answer. They want it to be harder somehow. They want the answer to be something like 5 up above. That for some reason, they'll set it equal to 0, and then they will tell me, what, if I set that equal to 0, I think I would get 18 out of that. Yeah. No, that's the answer. Don't do anything else. The same thing here. This means replace the x in f's rule of 1/3 x plus 6 with -2x plus 1 and simplify. And obviously you're not writing all that down, that's what you're thinking. So I've got 1/3 times -2x plus 1 plus 6 and simplify. So I'm going to distribute and get negative 2/3 x plus 1/3 plus 6. We want to combine these. So remember, to add fractions, we get a common denominator. 6 is the same thing as 18/3. And so my answer comes out to be negative 2/3 x plus 19/3. And again, we just stop. That's the answer. Okay, let's switch the function on us. Let's have f of x equal x squared minus 2x minus 4. Find and simplify each of the following. So f of 2, so 2 squared minus 2 times 2 minus 4, and so that's 4 minus 4 minus 4 for negative 4. Okay, again, if we look at the graph here, and if we go to x equal 2 and go right there, there's the point 2, negative 4. And again, we're trying to make that correlation that f of 2 equaled negative 4. X coordinates go in, y coordinates come out, and that's the same as 2, negative 4. Got a typo right there. That should say f of x right there. Someday I'll fix that typo. There's a little typo right there. But shown below is the graph of f of x equal x squared minus 2x minus 4. Again, observe the point 2, negative 4 is on the graph, and recall that f of 2 is negative 4. And again, what I'm really trying to beat here is that x values go into a function and y values come out. X's go in, y's come out. Let's work with this guy a few more times, and then we'll end the video. Same function, f of x equals x squared minus 2x minus 3. Again, it's a replace and simplify. So I replace all those x's, in this case with negative 3x, and I simplify. Very careful use of parentheses here. You want to square all of the replacement. So all of the replacement goes in parentheses, then we square it. And so I'm going to get 9x squared plus 6x minus 4. Stop. That's the answer. One more time, replace and simplify. So I replace all the x's with x plus 3. Again, careful use of parentheses. It's the entire replacement that is squared, so I need that in parentheses. Then simplify. I'm going to remember to FOIL that first term, distribute that negative 2, and so that's going to be x squared plus 3x plus 9 minus 2x minus 10. And so all I did there was FOIL. And then combine my like terms. So I have x squared, 3x plus 3x minus 2x for 4x, yeah? And then 9 minus 10 for minus 1, and stop. That's the answer. And that's where we'll end this video.